this video, I'm going to show you how to use the intermediate value theorem in problems. Let's remember the intermediate value theorem one more time. If we have a continuous function on the closed interval a, b, and if we take any number between f of a and f of b, where f of a is not equal to f of b, then there exists a number c in a, b such that f of c equals n. So how am I going to use this theorem to find the solution to the cubic equation x cubed minus 3x minus 1 equals 0 in the closed interval 1 to 3? So here I need to think about a continuous function. What is that continuous function? Look at the left side of the equation. You have a cubic function over there, and if you let f of x to be that function x cubed minus 3x minus 1, then we know it's a continuous one because it's a polynomial, and all polynomial functions are continuous functions. Alright, so we are done with the most important hypotheses of the theorem. We have a continuous function, and now remember our goal. We have to show that there is a solution of the given equation in that closed interval. In other words, we have to find the number c such that f of c equals 0 in the interval 1 to 3. Okay, so note that a equals 1 and b equals 3 here, and f of a is f of 1, which is negative 3, f of b equals f of 3, which is 17. F of 1 is a negative number, f of 3 is a positive number. And n is, from the theorem, is any number in between, right? N can be chosen to be any number between f of a and f of b. So it can be any number between which numbers? Let's write it, negative 3 less than n less than 17 here. Okay, and let's put this in the picture. I don't know the graph of this function f of x, but the situation is like this. So I have my function output value is negative 3, right? So this is the point on the graph of your f at x equals 1 and x equals 3. 317 will be on the graph of f, right? So look at it. This theorem says that since you have a continuous function between these 2 points or on this closed interval, right? And you can take any number in between negative 3 and 17, so that whenever you take that n, you will have an input with that output, right? That gives you that output. So can I choose here my n to be 0, right? Can we pick n equals 0 here? Yes, right? Because 0 is in between. So if we do this, then if n equals 0, right, if you choose it to be the origin, then we know that there exists this c in between such that f of c equals n, which is 0, right? So let's write it here. So choose n equals 0, then by the intermediate value theorem, let's abbreviate it with the IVT, then by the IVT, there exists a c, right, in 1 to 3 such that f of c equals n, which is 0 because you choose n to be 0. So you know that there exists this c, so there's a c, right, in this interval in 1 to 3 such that f of c equals 0. That's good. So we just finished the problem. It just says that this graph will definitely cut the x-axis, will cross the x-axis at least one point. But note that it doesn't say it will cross the x-axis exactly at one point. Maybe it will cross the x-axis like at three different points, right? Or 2 intercepts you might have, but for sure there exists one c value in between 1 and 3. Okay, so this will finish the problem, and let's see another problem now in the next video.